All right, so here is another example of a quadratic in vertex form. So right off the bat, hopefully you're recognizing with 2 times x plus 3 squared minus 5. This first value of a, 2, tells me since it's positive, it's going to open up. It also should be a little bit more narrow than the previous graph that you probably watched because 2 is a larger a value. It has a larger absolute value than negative 1. So first I've got I know it's facing up, and now I'm going to recognize what my vertex is. So I've got x plus 3, so that tells me my x value is negative 3. And I've got minus 5 on the end, so negative 3 comma negative 5 is my vertex. So I'm going to go over 1, 2, 3, and down 1, 2, 3, 4, 5. There's my vertex. And from that, I can recognize my axis of symmetry, which would be x equals negative 3. Axis of symmetry, x equals negative 3. And I will plot that here. Don't think I drew that over it. All right, so this starts really quickly because you already have your vertex and axis of symmetry given to you right there. So now I'm going to make my table and put my vertex right in the middle of it. 1, 2, 3, 4, 5. My vertex will be here, so negative 3 comma negative 5. So remember, these ones go in a number line order. So negative 3. 1 larger than negative 3 is negative 2. A lot of people mess with that. 1 larger than negative 2 is negative 1. And then 1 smaller than negative 3 is going to be negative 4 and negative 5. It can help you to kind of look at this number line and go from left to right. All right, so the first one I'm going to plug in is negative 2. So if I plug in negative 2, I've got 2 on the outside. Negative 2 plus 3 squared minus 5. So order of operations says do the parentheses first. So I've got 1 squared with a 2 outside minus 5. 1 squared is 1. So this is just 2 times 1 minus 5. Multiply these first. 2 minus 5. And I get negative 3. Using my axis of symmetry, I also know that negative 4 would get me a negative 3 as well. So I go over negative 2 comma negative 3. Use my axis of symmetry, and there we are. Now this makes sense because I can recognize this is going to face up, which I need it to do because I have a positive a value. So now I am going to do the negative 1. So I've got 2, negative 1 plus 3. So I've got 2 times 2 squared minus 5. So 2 times 4 minus 5. And then I've got 8 minus 5, which is going to give me 3. So I've got negative 1 comma 3. And negative 5 comma 3 as well. And then I'm just going to make my nice little parabola. Notice I had negative values for the x values of negative 2 and negative 4, but then I had positive values for negative 1 and negative 5. So my x-intercepts are not actually going to be exact points. They're going to be somewhere between negative 2 and negative 1 and negative 4 and negative 5. So they're not going to be exact in this situation. If I wanted to find the y-intercept, notice I haven't hit it yet. I can find the y-intercept by plugging in 0 into the equation. So if I plug in 0, I get 2 times 0 plus 3 squared minus 5. So that's 2 times 0 plus 3 is 3. So that's 2 times 9 minus 5. So I get 18 minus 5, which is 13. So this would be my y-intercept. And notice it would be way up there. Keep going up.